I am Ivan Michael Siachensa of Batangas State University, Bachelor of Science Information Technology. So for today's video, I'll be doing activities in Chapter 7. I think there are 9 or 10 activities in Chapter 7. So the title of Chapter 7 is, the title of the chapter is IP addressing. So I think all the activities here are related to IP addressing, conversions, and let's start with the first activity. So the first activity is in page 7.1.1.8 and it is entitled Decimal to Binary Conversion Utility. So let's open it. The instruction is, this activity allows you to practice decimal conversion to 8-bit binary values. We recommend that you work on this tool until you are able to work to do conversions without error. Convert the decimal number shown in the decimal value row to its binary bits. So from what I know, to answer this activity, we must base on the decimal value. Right here it's 51 and the position right here. So what we're going to do is to see if we can subtract 51 to the positions here, and if we can subtract, we will put 1 it, and if the answer is negative, we will put 0. So we can subtract 51 and 28, the answer will be negative. 51 and 64 will still be negative. So 51 and 32, we can subtract that. So 51 minus 32 is 19, so we'll put 1 here, and the answer is 19. So we will see if we can subtract the subtracted value to the next value here, 16. So 19 minus 16 will be 3, so we'll put 1. We can subtract 3 minus 8 because the answer will be negative 5, so it will be 0. 4 minus 3 will be negative 1, so still 0. And 3 minus 2 will be 1, so we'll put 1 here. And 1 minus 1 will be 0, so I think we'll put 1 there. So let's check. Here it says the binary values you have entered for all positions are correct. Please click new number to continue. So let's try it again. So the value here is 125, and if you subtract it to 128, the answer will be negative 3, so I'll put 0 here. So 125, we can subtract 125 to 64, so 125 minus 64 is 61, so we'll put a 1 there. 61 minus 32, the answer will be positive there, so the answer is 29, so we put 1. We can subtract 29 with 16, let's put 1 here. 29 minus 16 is 13, so 13 minus 8 will be 5, so let's put it there. Put another 1, so 5 minus 4 will be 1, so let's put another 1 here. So the remaining value is 1, so 1 minus 2 will be negative 1, so put 0 there. 1 minus 1 is 0, so we'll put 0. So let's check. Correct, the binary values you have entered for our positions are correct. So let's try for another one. So the value is 219. So 219, you can subtract that to 128. 119 minus 128 is 91. So we'll put a 1 there. You can subtract 91 to 64. Will be 27, so we put here 27 minus 32 will be negative 5, so let's put 0 there. 27 minus 16 will be 11, so let's put 1. 11 minus 8 will be 3. This one. 3 minus 4 will be negative 1, so let's put a 0 there. So 3 minus 2 will be 1, so let's put a 1. And 1 minus 1 will be 0, so let's put another 1. Let's check. So correct, binary values you have entered for all positions are correct, so we have answered that activity correctly. And now let's go to the next activity. So the second activity is in page 7.1.3.7, and it is entitled unicast, broadcast, or multicast. So let's open this activity. So the instruction is click start to view the destination IP address. So if you click start, the IP address will be shown here. Next, click the host, which will receive the packet based on the address type, unicast, broadcast, or multicast. This is a timed activity, so there is only 10 seconds to answer. Once we click start, the 10 seconds will start to count down. Destination IP address will be shown, and we will choose from which PC the packet will be sent. So it will differ from unicast, broadcast, or multicast. So it depends on the destination IP address. So let's click start. The IP address is 192.168.100. So this here it is. So it is a unicast. It will be sent to only one PC. It says you have successfully identified the transmission type. So let's reset. Let's try again. Let's click start. The IP address 192.168.100.2. So the PC is this again. So it is another unicast. So let's stop, reset, and let's start. The next IP address 237.192.17. So here and here it is a multicast. And let's click reset again. So let's start. So it's another one here. I forgot to reset it. So let's start. 192.168.100.5. So it is here to find this PC. It is a unicast. Sent to only one. You have successfully identified transmission type. Let's stop, reset, and let's try another one. 237.192.1268.17. So here is and this. So it is a multicast. So we have correctly answered that. So let's proceed to the next activity. For the third activity, it is in page 7.1.4.8, and it is a public or private IPv4 addresses. We will identify if the IP address is a public IP address or a private IP address. So for us to answer that, let us first look in the page 7.1.4.1, because here you will learn how to distinguish if it is a private or a public network. So specifically, the private address is blocked, so it means that the range of the private address is from 10.0.0.0 to 10.255.255.255.255 and 172.16.0.0 to 172.31.25.25 and 192.168.0.0 to 192.168.255.255. So those are the IP blocks for the IP address for the private IP address. Let us now try to answer the activity. This is entitled public or private IPv4 address. So the instructions read each IP address to the correct category, public or private. So we have here the IP address, and we will categorize it for public and private IP address. So let's start. So 192.16.35.2, I think it is a private network depending on the range. 192.168.3.5, from what we have seen from the last slide, it is a private address. So 192.0.3.15, it is a public because it is not in the range of the private addresses. 64.104.0.22. It is not in the range of the private address. 209.165.201.30, it is in public. 192.168.11.5 is another private IP address, and 172.16.30.30 is in private. And lastly, 10.55.3.168 is in private network. So let's check. It says correct. You have correctly identified all the IP address, so we have answered that activity correctly. And now let's proceed to the fourth one. For the fourth activity, it is in page 7.2.2.4, and it is entitled Practicing IPv6 Address Representations. So let's open it. The instructions: convert the IPv6 addresses into short, omit the leading zeros, and compress forms. Use the numbers at the bottom of the page to continue this activity. So there are 10 figures. So here are the preferred format: omit leading zeros. So we'll put the omit leading zeros, and compress format. So let's try to answer it. 2001. So it is, we'll omit the zero, so let's put just 1 0. It is another leading zero, so let's just put DB8. And 111. Eliminate the other zeros, 0 0 0 and 200. Now let's compress it. 2001 0 DB8. So there are 3 zeros, so let's not put it. So 200. See, so the answer here is wrong. We forgot to put the 111. There, it's correct. Now figure 2, 213, 0, 1, 1, 2, 3. Let's make the leading 0, 4, 5, 6, 7, 8, 9, AB, C, D, E, F. Let's put 1 0 and 1. Let's try to undo 1 3 0 1 2 3 4 5 6 7 8 9 A B C D E F 1 0 and 1. Let's see. So it's wrong. Try to eliminate this 0. Let's check. There, we got the correct answer. So here, but 1 0 0 0 0 0 0 and 1. So the zeros, we're going to omit it. I think this is the answer. Let's check. It's correct. For the fourth figure, 2012 ABCD EF01 2 3 4 5 6 7 8 9 10 AAA BBBB. So let's compress it. ABCD EF01 2 3 4 5 6 7 8 9 10 AAAA BBBB. So let's check. It's correct again. For the fifth figure, AB1E 2B00. So let's put 1 0 here. Omit the leading zeros. 1 2 3 4 5 6 7 8 9 1 0 1 1 1 1 2 and 1 1 1 3. Now let's compress it. AB1E 2B00 and 1 0 1 2 3 4 5, 6, 7, 8, 9, 10, 1, 1, 1, 1, 2, 1, 1, 1, 3. So let's check. We got it wrong here. So AB1E, 2B00, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 1, 1. Let's try to erase the 0 and check. There, we got the answer. Here in figure 6, BB2B, EF12, DFF3, 9125, 1111, 101. Let's omit the leading 0, 1111, omit the another 0, 101, BB2B, let's compress it, EF12, BFF3, 9125, 1111, 101, 1111, 101. So let's check. Got it correct. Figure 7, 1129, 1984, 22233. No leading zeros to eliminate. 6677. So we got here. Let's eliminate the leading zeros. 101. Now let's 1129. Let's compress. 1984, 2233, 4455, 6677, 20. So we're gonna omit that. 101. Let's check. So it's correct. We got them all. So here in 8. So let's put this 111. And this is just 0, 0 here, 0, 0, 0, and this is 101, and this is 1111. So I've already answered this a while ago. So this is the compressed format. Let's check. Let's try figure 9, 1031, 1976. So omit the leading 0, so just 1, just 2 and 3, just 4, so just 1 here and 101. Now let's compress. 131, 1976, 1, 2, 3, 4, and 0 and 1, 0, 1. Let's check. It's wrong. I think I always put this here, so yeah, I always forget to eliminate that 0 in compressing it. Let's hit the figure. 0, 0, 0, 1, 2, 3, 4, 6, 6, 7, 8, 9, 1, 0, 1, under 0, and 3, 4, AB. So let's compress. We have leading 0, so I think I'll just put like it just like that. 1, 2, 3, 4, 6, 6, 7, 8, 9, 1, 0, 1, and 3, 4, AB. This one is pretty difficult to compress. Let's check. I think I need to put 1, 0. I'll put the 0 here. This one is really difficult. Can't manage to answer this number 10. So I don't know the answer here. Can't answer this, so let's just move on to the next activity. So the next activity is in page 7.2.3.5. This is entitled Identify Types of IPv6 Addresses. So let's open it. The instruction is drag the IPv6 address type to the most appropriate description. So here are the terms. We will choose between from the three choices: global unicast, link local, and 64. The description unique. Here the description. Let's read it and identify. Unique internet routable IPv6 address, dynamic or static. It is I think it's definitely a global unicast. FE801, it is a for the link local, and 201 DB8ACAD, it is a global for global unicast. A typical IPv6 prefix used to indicate the network portion of the address, it is a 64. Used to communicate with other devices on the same IPv6 subnet. The same IPv6 is in a local, link local. Let's check. Correct, you have successfully matched the IPv6 address types to their description. So on to the next activity. So here is another activity. It is in page 7.1.1.5 and title is binary to decimal conversion activity. Instructions is this activity allows you to practice 8-bit binary to decimal conversions as much as necessary. We recommend that you work in this tool until you are able to conversion without error. Convert the binary number shown in the octet to its decimal value. So a decimal value will be shown here, and we will so the bit here, and we will place the decimal values. So just like here, it's the bit is in here and in here, so we add 32 plus 4, so it's 36. Let's check. 36. Let's check. It says correct. You have entered decimal value you have entered is correct. Let's try a new number. So what we do here is we add the positions with the 1 beneath it. So just like here, we don't put 1, 2, 8, 64, 32, and 2 because beneath them are the bits of 0. So let's try 16 because it has 1 beneath it, 8, 4, and 1. So the sum of all of that is 29. So let's put 29 and check. Correct, the decimal value you have entered is correct. Please click new number to continue. Let's try another one. So 64 and 1, so it's 65. Let's click 65 here and check. That's so correct again. The last one, we don't put 1, 2, 8, 64, 16, 8, 4 because there are zeros beneath them, so we only put 32, 2, and 1. So the sum of that is 35. Let's put 35 and check. Correct, the decimal value of entered is correct. Please click new number to continue. I've answered that correctly. Let's proceed to the next activity. So this next activity, it is an activity but in a form of a game. So the title of the game is a binary game. So let's try to play it. So I'm gonna play it for the first time. So let's play it. So 5 plus 5. I think put so we're just going to put that. I think it's 3. We're just going to put all the answers here. 16, just put here. Eliminate this. This is 164. So this is how the game works. So we're cleared that board. So this 4 is this 64. I'm just going to eliminate the easiest. So I 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is equals to 256. 256. No. Let's eliminate this first. This is 4. Let's eliminate the easy ones. 33 is this. So let's try this again. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is 250. It's 250. Oh, 250. Still 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 255. This is 8. This is supposed to be 1. It's 0. 32. Oh, 16. Level 1 complete. So level 2. This is 34. So 127. Let's just try this first, easier. This is 11. It's 10. 127 is so 64 and 32. 64 plus 32 is 96 plus 16. 112 plus 8 is 120. So let's put this here, there, and this is going to be 2. It's 128. So this 65, get 65 is this. So 32 plus 16 plus 8 plus 4 plus 2 plus 1 63. This 6. And this is a very fun game to play for us to learn binaries easily. 240, this is 240. So get 2 here, and this one 1. So we have a score of 3,500 as of now. We need 131, so 128, 2 and 3. 1 is here, 32 plus is 36. 34, we need this. Clear that board. So 128 plus 64, and 28 plus 64 is 192. If we add 32 is 224 plus 16 is 240 plus 8 is 248 plus 4 is 252 and plus 2 is 254. It's getting kinda hard now. So 128 plus 2 is 131, 31. So 2 this, 37 is this and this. Level 2 complete. It's getting kinda hot. Oh, if we need 10 is this and this. So 65 is 64 and 1. 2 is this 2. 41 is this. 131. We need 3 more, so 2 plus 3. Board clear again. This is kinda hard again. 128 plus 64 is 192 plus 32 is 224 plus 16 is 240 plus 8 is 248 plus 4 is 252, so plus 2 is 254, so here is 254. 11 is this and this, so 248. Let's answer that later. 64 plus 8 is 72 plus 4 is 72 plus 4 is 76, I think. This is 250. If we need 128, just put this, eliminate this. So 32 is this, 132 is here. We need 4 more, so there. And 248. All of this, I think, without 2. No, all of it's 255. So we need to eliminate 7. So this. So 3, we need 3. Just need 2 and 1. 127. Let's answer that later. 16 is 8, 16 is here, and 6 is 4 and 2, and this is 64, 32 plus 2 is 34, is 0. 251. We need 251. 128 plus 128 plus 64 is 250. Oh, we just all of this is 255. So we put all of it and minus the 4 here. So it's 130. There, and 192. We need 190. That's 225. If we need 225, please eliminate 20. So 16 and 4. I think. I know 30. We need to eliminate. Oh, it's now giving us a warning. So 10. Oh, game over. I just scored 8,000 points. So that is all for the binary game, and let's proceed to the next activity. So here's the next activity. It is in page 7.1.2.4. The title is Ending and Determine the Network Address. So the instruction is use the ending process to determine the network address in binary and decimal formats. So to answer this network address in binary, we just compare the host address in binary and subnet mask in binary. If it is 1 and 1, we just put 1, and if it's 0, 1, or 1, 0, or 0, 0, we put 0. Just like here, 1 and 1 is 1, then 0, 1, we put 0. So 1, 1 again, we put 1, 0, 1, 1, 0, 0. So to the next one is 0, 0, 0, because it's 3 0 1s, and 1 here was 1 1, 0 0 and 1 1. So the next one is 1 0 1 0 1 0 0 1, and lastly there's no 1 1 if we compare them, so we just put 8 zeros, 6 7 8, there, and network address in decimal. We're just going to convert this, our what in the network address that we have gotten. I'm just going to convert it to decimal. So because it's 1010110, we just add 128 plus 32 plus 8 plus 4. Answer is 172. So we'll just put 172 here, and because it's here, it's 0001011. We're just going to add 0000001 0011. We just add 16, 2, and 1, so it's 19. Here we're just going to 1 0 1 0 1 0 0 1. So we just add 128 plus 32 plus 8 plus 1. So the answer will be 169. And the answer here is 0 because it has no value there. So let's check. Correct. The binary and decimal versions of the network address are correct. Please click new number to continue. So we have answered that correctly. And let's try the next activity. So here is our next activity. It is in page 7.1.4.2. The title of this activity is Pass or Block IPv4 address. So the instruction is decide to pass or block each IP address depending on whether it's public, the internet, or private small local network. Click start to begin and click on either pass or block. So there will be an IP address shown, and we'll just decide if to pass it or block it in the ISP. So let's start. I think this one is pass. This also, you just have to decide to pass it or block it. This one is to pass. This one will pass too. I think this one is pass. Correct, you have successfully identified public and private IP address. In the first, I think at first 3 we got it wrong, but I managed to score 10 points. So let's proceed to the next activity. So I think this is the 10th and final activity, and it's in page 7.2.1.3. The instruction is drag the IPv4 and IPv6 term. So here are the terms: dual stack, IPv4, tunneling, IPv6, and translation to the field next to the appropriate description. So this is the place where we're going to put the term. Here's the description. Let's read the first description. 128-bit address, 340 undecillion addresses. So I think it's an IPv6, and the next is 32-bit address with 4.3 billion addresses. It's an IPv4. Transports an IPv6 packet over IPv4 networks. It's tunneling and uses NAT64 to convert between IPv6 and IPv4. So the keyword here is to convert, so I think it's translation. So the last one, dual stack, allows IPv4 and IPv6 to coexist with each other, so it's dual stack to IPv and the same network segment. So let's check. Correct, you have successfully matched the IPv4 and IPv6 term to their description. So we have answered all the activities in chapter 7. That's all, and thanks for watching.